Hello, welcome to the fourth lecture of Computer Skills module. This is your instructor, Dr. Murat Tunç. Today, we are going to talk about functions and how to write our own function in Python. But before we do that, let's start with a summary of last lecture. In the last lecture, we learned the new data type, that is Boolean. So Boolean data type is either true or false. So it can be true. You can think of true as 1, false as 0. This is how the computers operate. And just like we have in mathematics 1 plus 2, 1 minus 2, in Boolean functions we have a comparison operator. So this is a comparison. So most of the times in programming, we need to compare two values or one variable with another value. So the motivation for this particular data type was, in the first example, we asked the user to input the radius of a circle, but what if he enters a negative radius? So that's why we need some comparison. For instance, radius greater than 0 was our motivation. So in this particular example, we have comparison 1 greater than 2. This is false because 1 is smaller than 2, right? So here B is assigned to value false. Okay. We have 6 comparison relational operators. So just like in math, we have less than or equal to. So you write smaller and equal sign. So greater than and equal to, double equal sign. So this is important because usually what we have is in mathematics is just equal sign, right? But in computer language, we have double equal sign. So be careful if you do radius equals 0, what it does is, this is an assignment. So it assigns 0, the right-hand side, to the left-hand side. But if we do radius double equals 0, so now this is a comparison. So this is a comparison. So what it does is whether the radius, the value of radius is actually equal to 0 or not. So assuming radius is 5 in this example, radius is 5 is not equal to 0. So this is a false proposition. Then we have not equal sign. We use an exclamation mark and an equal sign. And then we learned one-way if statements. So a one-way if statement, you only have some statements only when this expression is true. When it is false, you don't do nothing. You just skip if false, right? You only execute these statements under the condition that Boolean expression is true. And we also have a two-way if-else statement. So now we have an else accompanied with the if. And we also talked about the alignments of this one. So whenever we have an if statement, the statement is one tab away. So this is in Python, this is for blanks, or for spaces. So you have basically a tab. So if you click on tab on your keyboard, you go for spaces away, right? So the statements for the true case needs to be one tab inside of this line. But the else statement should be aligned with this so that we know that this else belongs to this if. So they are connected. So this is the statement for the false case. So previously, when it was false, we don't do nothing. But in this example, when it is false, we actually have certain statements, but only if it's false, you execute them. When it's true, you skip this part. Skip if true, but this one, you skip if false, right? So depending on whether it's true or false, you only execute one of them. You never execute both of them at the same time. And then we have logical operators. So they're quite straightforward. If you have a not, you sort of take a negation, the negative of it. If it's true, becomes false. If it's false, it becomes true. Just the opposite sign. So you have and. If we have two propositions, P1 and P2, when you have and, you need both P1 and P2 to be true, otherwise it's going to be false. And then you have or. If you have two propositions here, you need either one of them being true is fine with you. And this is the truth table for operator and. So let's assume that you have proposition 1 and proposition 2. And the propositions are, so this is one proposition, this is P1. And this is the second proposition. So here we have false and false, because we assume age 24 and weight 140. If that's the case, the end result is false. The end result is, you can see it here, and the corresponding P1 and P2 you'll see just underneath this column, okay? So these are the values for P1, these are the values for P2. And the end result, P1 and P2, is true only if both of them are true. So if age is greater than 18, that's a true, and the weight is greater than or equal to 140 pounds, then you have a true case, okay? And this is the truth table for OR operator. So we have P1 and P2, and these are the according values of P1 and P2. Again, this one is P1, and this one is P2, and these are the assumed values. So we have, if it's false or false, then it is false. All the other cases, the end result is true, because this is an OR operator. OR just needs one of them to be true. That is sufficient. So we have true here, true here. Both true is also fine. If that's the case, the end result will be true. But if neither of them are or true, or both of them are false, then the end result will be false. And then I ended up with two practice exercises. I hope you were able to practice them. If not, it's not a worry, because I'm going to do it right now in front of you. So in this example, we were asked to write a program that prompts the user to enter a movie's IMDb rating from 0 to 10 that may include decimals like I don't know, 6.5 or 3.5. And then there's the Metascore. And that's going to be integer between 0 to 100. And then after taking these two ratings and scores, we check whether this movie is recommended to watch or not. So we are going to recommend if the rating is strictly greater than 7 and the Metascore is strictly greater than 60. All right. So this is the program. So let's do it. So this one is practice exercise 1, and this one was from lecture 3. Although we are in lecture 4, we just follow through the lecture 3's practice exercises. So okay, so we have step 1. So we input IMDb rating and Metascore from the user, and then we decide recommend watch. Check if the movie is recommended to watch. Okay, so 2 steps, pretty straightforward. So I'll go IMDb rating, and then I'll define Metascore. So I'm going to input, and I'm going to take it and convert it to a float, because so if you check, the IMDb rating can include decimal, so this is definitely a float. But the Metascore is integer, so this is int, right? So they are by definition, so I don't. I'll just directly convert them to float and integer. So please input the IMDb rating of the movie. Okay, and then we input here. Please input the Metascore of the movie. So we take them. Last, we have an if and else statement. So here we have the condition to recommend, right? And then we print this movie is recommended to watch. For the else case, we just go, this movie is not recommended to watch. Okay, pretty straightforward. So what is this condition to recommend? So this is also given in the question. The condition is if the rating has to be strictly greater than 7 and the Metascore strictly greater than 60, right? So here it goes. We have IMDb rating strictly greater than 7. You can write 7.0, doesn't really matter. And Metascore should be strictly greater than 60, right? Yeah. All right, so that's the program. Let's run it. Please input the IMDb rating, let's say 7.6. Oh, okay, here. So we have double int. All right, so let's go 7.6, and then the Metascore. Please input the Metascore, let's say 52, 53, and then it's not recommended to watch. Here now we go 6.5 and then maybe 92. This happens sometimes. And this is again not recommended to watch. Let's say 7.1 and 65, 64. Then it is recommended to watch. All right. So you can also see another version of this code. All right, so the second practice exercise. So now we are asked to write a program that prompts the user to enter the date, day, month, and year that they were born. And then afterwards, you're going to display whether he or she can legally purchase beer in the United States. And the legal purchasing alcohol age in the United States is 21. So we go, give me a beer, please. And then the bartender says, can I see an ID? And then now it's your turn to input your date of birth. And then the bartender decides to give you the beer or not. Okay. So let's do it. This is practice. Exercise 2. So that's step 1, right? Input the date of birth. Step 2, now check whether you can purchase a beer. Okay, so the date of birth consists of 3 parts, right? So the day, so you have the day. So we go, so all these are integers, so that's why we go int. Please input the day of your birth, and the month. It's like similar. Please input the month of your birth date. And then the year, right? So int input. Please input the year of your birthday. Okay, so we have day, month, and year from the user. Okay, so here, now we are going to check whether they are above 21 or below 21. So I intended to put this lecture online on the 30th November 2021, right? So if you're born 30 November 2000 or earlier, so you can purchase a beer, right? Otherwise, if it is 30 November, or we'll just do the rest as an else, right? So here we have if and else. So let's put this. If the birth date is 30 November 2000 or earlier, we go, here is your beer, and then I'm sorry, I cannot sell you a beer. Okay, so now we need to figure out a way to create a condition for 30th November 2000 or earlier. Okay, so we can do it in a couple of ways. If you're actually born before 2000, then that is clear, right? So you are 100% guaranteed to be over 21. So that's one proposition. Or if you're born in 2000 and you are born in the month before November, then you can also purchase a beer, right? Or if you're born in 2000 and you're born in November, now you must born before, let me actually think. So November, is there a 31st of November? Probably not. So we can just go by greater than or equal to 11, right? Right, because 30th of November is the last day of November, so if you're born that day, you can still purchase a beer. Only if you're born in December 2000, then you cannot purchase a beer. And any year that is less than 2000, that's also cool. Okay. Okay, awesome. Please input the, so I was born in 30 June 1990, so I get a beer. Depending on your age, you may or may not be able to buy a beer in the United States. Okay, cool. So let's start. So here is another. I actually have the 30 less than or equal to 30 and 11 here, but apparently it's not needed. So you can just skip yourself a line, or you can just play safe. Okay, so now we are going to start functions. So the motivating problem is the following. So let's say that we are asked to find the absolute difference between two numbers, and we were given two numbers. Okay, so we were given number 1 and number 2. So we were asked to find the absolute difference between the two. So the absolute difference between the two here is 3 minus 10. That is 7, right? Here 2020 minus 65, that is 43. And this one minus 99 is 16, right? Okay, so we were able to write it down mathematically, but we need to write it down computationally. So here is a tedious way. So you can write the same code 3 times. So you can define num1 and num2 3 times separately, and then check if num1 is greater than num2, then the difference would be because this would be positive, right? Or so if actually num1 is less than num2, so this is the false case, then you have let's actually follow this code. So you check whether 3 is greater than 10. So this is a false proposition. So we go to else state, else block. So the absolute difference for us would be 10 minus 3, which is going to be 7, right? So we can do it either tediously, we write everything down, but there is a easy way to write it. Because if you noticed, the code in the blue square, like this code, like this one, oops, and this one, right? So these codes are exactly the same, except for the numerical values. Otherwise, they're exactly the same. So these 3 codes are exactly the same, except the 2 numbers, the values of the 2 numbers, right? So if you sort of ignore these 2 values, they're exactly the same. So how shall we find a way to not repeatedly type the same code 3 times, but just write it once and then reuse it? So this is the idea of a function. So here is the observation is that all the 3 cases is similar except the starting and ending integers. So it would be actually really nice if we just write a common code and then reuse them. So that's what we call a function. So let's say that inside this blue box, we have a function. So here is our blue box. And here is the function. The function name is my difference, and the function inputs are x and y. So we are going to learn the inputs today in this class and the function name. And we actually don't need to know the exact details of this function. What we just need to know is that it is a function that returns the absolute difference between the two numbers x and y. So that's all you need to know. You don't need to know what the code inside. You just need to know how to use it. So you give in two numbers, x and y, to this function, and then what you get out of it, so that returns to you the absolute difference between the two. So if we write the absolute difference between 3 and 10 is, and then here is the function my difference 3 comma 10, this will give us 7, because we call this function by its name, and then we give in two inputs, right? And we were told that this function returns us 7, the absolute difference between 3 and 10, as a result. So now we are safely assumed that this function will give us 7. This function will give us 43, and this call will give us 16, right? Without knowing what the function includes, we just know for sure that this will return us 16, 43, and 7, respectively, okay? And here is the inside of this function. So we go def, def, so this stands by define, the function name, and the inputs. Currently, we don't know what these inputs are, but we are going to write a code on them. So without knowing what they are, they can be any numbers. So we have no prior information. We just check if the first is greater than the second, we go first minus the second. Else, that is, if the second is greater than the first, then we go second minus the first. Finally, we return the absolute difference that we calculated here. And then if you go print my difference with two numbers, so this is how you call, but then here you would need to give in the actual values, like 3 and 10, or 22 and 65, I guess. So this is how it works. So you define the function over here. So this is the function definition. And here is how do you use the function. So this is the function usage. So we only write the name, this exactly the same, and then we give two numbers, num1 and num2. Okay. So you can think of the function as a black box. You don't really know what the detailed implementations are. You just know the header. That is the name of the function. The name and how many inputs it receives, right? That's all you need to know. You don't need this black box in here. No need to know this. Okay? So just think of it as a black box. You just know what it does and the name and how many inputs that it receives. So functions, so we use functions to define reusable code, basically to simplify our coding and save some time. We already used some built-in functions defined in the Python library. For instance, we use print. So print is a function. we don't know what it does, we just know how to use it. We already use it, right? So input is another built-in function. So some person writes input function in Python, and then we are using it. But we didn't write it. We don't know how it's implemented. We just know how to use it, right? Similarly to the power. So we have two inputs here, let's say 2 and 3. We know that this will give us 2 to the power 3, that's an 8. We just know that. We don't know how it works, right? So how do we create our own functions? So we can first define a function and then invoke it. So a function consists of a name and a list of the parameters and a function body. So here you have the name, right? You have the list of parameters, and you go inside with one tab inside, just like in if and else. You write the statements. Okay, here it goes. So you have my difference, num1 and num2. So this is the function name, and these are the formal parameters. And then inside we have the function body, and this is the return value. So this, like all of it is the header, but we have the name and the parameters are separately. So these are called formal parameters because we don't know the actual values. So they are just placeholders for the actual values. Here, when you invoke a function, when you actually call the function inside your print statement, for instance, you call the name and then you give in the two actual parameters. So this was formal parameters, this is actual parameters, they're also called arguments. So if you do it, what happens is this 3 goes num1 and here 10 goes num2. So we have if 3 is greater than 10, this is a false proposition, so we go to else case, and then we go num2, which was 10, minus num1, that is 7, and this 7 is returned, right? So we return 7 as a value back to where we started. So we call it, the numbers goes inside, the calculations happen, and then the return goes back, and then we print 7. So here we print 7. That's all it does. Okay, so the function signature is the entire thing here. So you have the name, the combination of the name and the parameter list. And these two are the formal parameters. They're not values yet. They will be values in a second. Okay, so here we defined a variable. So this is an assignment, right? Assign right-hand side to the left-hand side. But what is right-hand side? We don't know. The right-hand side invokes a function with two actual parameters, 3 and 10. When you invoke these two parameters, these two parameters will pass the actual value to the placeholders. The placeholders are the formal parameters, right? And then the values become some actual value. Instead of num1 and num2, we actually know that they're 3 and 10. So here's the thing, the parameters are actually optional. So a function may contain no parameters. So it's not a must, it is an option. But if it includes, then we have to write in the actual values 3 and 10. Okay, and then the function may or may not return a value. So this is also, so the two things, one, the function with or without parameters. So it's not a must. It can be without parameters as well. The second thing is the function can be or can be without return value. So again, it's not a must. It can be both. It can be either something that returns. Here we have a function that returns a value, or we can write a function that returns nothing. That's also a possibility. Okay, so let's do a couple of exercises. So here, what is the value of integer? So this is our function definition. And down below, we have an assignment that assigns right-hand side to the left-hand side. So we have an integer variable. It is so a memory space is allocated inside the computer, but so far it's blank. So what do? We invoke this function with two parameters, 5 and 14. So they go, so 5 becomes num1, 14 becomes num2. And what do we return? We return num2, 14 minus 5, 9, right? So 9 is returned to integer. So that is the value of the integer, it's 9. So we invoke my integer with actual parameters 5 and 14. And then my integer returns the value of 14 minus 5, that is 9. Okay. Another example of what is the value of integer. So this, my integer 5 and 14 goes to, so here be careful because what I have is num2 first, num1 second, right? So num2 is first, 5 is first, so 5 will be num2, 14 is second, and num1 is second. So make sure that they go to the same place. So don't assume that num1 is before num2. Just align the places, right? So if it's first, it goes to the first one. If it's second, it goes to the second one. And what do we return? We return the remainder 5, remainder 14. So let's do the calculation. 5 by 14, it's 0. This is again 0, so the remainder is 5. So answer is 5. So my integer is invoked with 5 and 14. It returns 5, remainder 14. So if we divide 5 by 14, the remainder is still 5, right? Okay, so now num1 is 5. See, num2 is 14. So what do we return? We return num2 by num1, right? So we return 14 by 5, which is 2.8. So again, similarly, it goes the same way. Okay, so this would be just a little bit different than the previous one. So here again, num1 is 5. right? So this is the first one, this is the first one. Num2 is 14. So inside we return 14, integer division 5. So if it is simple division, we would give 2.8. But since this is an integer division, remember last week, what do we do here? We delete this 0.8 and the result will be 2. Okay. So again, invoke with actual parameters 5 and 14. This means integer division from last week. And then we divide, we find 2.8 and the integer part is 2. Okay. All right, before we start the second half of this lecture, let's give a quick break. So I'm going to stop this video now, and then we will start off the second part of this lecture by value returning function and void functions. Okay, see you in the next part.